It's great to be here. Thank you so much for having me. I love being here, by the way. I used to give talks a lot, but now I haven't given a talk in maybe 4 or 5 years, so I might be a little bit rusty. So just bear with me here. I thought it would be fun to. Also, I do know un peu French. I know merde. So. I thought it would be fun to talk about how we run our cluster, and then I have some fun stuff about some incidents that we have, totally unrelated to Kubernetes, just because they're interesting. For those that don't know, I started a company with some other folks. We do CAD, and so we built our own CAD engine, which that just came around from my own overconfidence, how hard could this be to build a CAD engine? Nobody's really done it in 80 years, or in 30 years since the 80s. We built a modern CAD engine with a real API. We also built a programming language on top of it called KCL, which stands for Kitty CAD language. And then we built an IDE for our CAD engine and the programming language called Design Studio. And so as you click and point in the IDE, it generates code. And so most mechanical engineers don't actually want to interact with the code, but then after they see the code generating, they're like, oh, this is cool. I can change this variable, and then everything transforms, which is kind of the point, which is dope. We kind of just made CAD into something that has APIs and stuff, which is not how it works traditionally. So it's been fun and very interesting. And the reason why we did this is because at my previous startup to this, Oxide, we were building rack scale servers. And so that was my first entry into doing anything with hardware. And so we were using SolidWorks, which is one of the incumbent CAD programs. And 2 people couldn't be working on the same file at the same time. And then we'd be passing files over to the industrial designers who worked at a design agency. And they would get them and change things on the outside of the rack, and then they'd send it back to the mechanical engineers, and they'd be like, you moved these holes, now the rack's going to explode when we run the simulation. And I'd be like, why are we passing files and not doing this in a PR? And it would just take a really long time, and there were a lot of humans involved, and it just seemed like something where if we used the software workflow for hardware, it would become a lot easier. And so after talking to a bunch of people that worked on hardware, I was like, this doesn't exist. And so me and my co-founders decided to start it. So that's kind of how that came to be. The way that we actually run our infrastructure is a lot of GitOps. We use Argo, Gatekeeper. We do autoscaling. We use batch jobs for conversions. We actually have we can fine-tune ML models on customers' existing incumbent files, because we get the feature tree, the CAD feature tree for them, then we convert it to our language. And so we run a lot of batch jobs, millions of files. And then, we use object storage and OpenTelemetry for tracing, which thank God we have fucking tracing. Sorry. I don't know if I'm allowed to curse. That's going to happen. The folks that use it are mostly engineers, and also hardware engineers who also work with software folks, so they see the win with writing code. And you can push it to Git and actually read it, versus it being this proprietary file that is not text-based, and you can't look at a diff of it. And then a lot of folks use it for in agentic workflows. So you can take the code, change parameters, run a simulation, and then kind of brute force I want it to hold this mass, this weight, but be the lowest mass possible. And traditionally, you would use something like N-topology. I don't know if any of you have heard of that, which would use algorithmic ways of doing that, and it creates a kind of mesh. But you can actually just brute force it with parameters changing and running simulations, which is cool. Sorry, ignore my pop-up. So this is a network diagram that I stole from our Git repo. I don't know who made this, but it's really good. Should probably give them a raise. This is really nice, and it's actually up to date. I mean, most diagrams in our repos are sorely out of date. This was probably because of our SOC 2 audit. But this is kind of an overview of what our infrastructure is like. And so our the engine itself runs on GPUs, and we actually don't need the most powerful GPU. We can use desktop GPUs, which are super awesome. And we do run some desktop GPUs internally in our office. Not in a data center, though, because that's against their rules. So we like the most probably interesting part of our infrastructure is the engine, and then a bunch of like the batch jobs. We use Cockroach as our database. Thank you to them because that has actually been insanely seamless. And then we actually, like, for the CAD app itself, it's Electron-based, which I know, like, but we have a lot of performance benchmarks around, like, startup time and stuff like that so that we make sure that it's fast. So you can have, like, a good Electron app, which VS Code proved in and of itself because it's great. And then for the website, like, all of the kind of front-end, just, like, pure React things are hosted on Frazelle. And we're obsessed with Tailscale. I love Tailscale. Oh, my gosh. And then we use Cloudflare for DNS. So this is also like a rough architecture. So we have this like engine manager thing, and each CAD engine itself, like it has to acquire a session and give them out. And you'd think that would actually be like where most of our incidents come from, and it's not, because it actually works insanely well. But yeah, this is just high-level overview. So here's what I thought would be interesting is because like our cluster is like actually like relatively boring because like not a lot of things go wrong. It's mostly like the things that go wrong are like, well, I'll go over them, but they're fairly interesting stories, and I thought it would be fun to do that. So these are like our top 5 incidents. One of these just happened, and it was my fault. Yeah, mostly yeah, I've been like, for the last like 4 years, I feel like I've been like coding in a dark room, and I haven't like gone outside. So definitely some of this is my code. Yeah, so let's start with the first one. This was my fault. We used to do, for like our subscriptions, we used to like hard code them as constants in code because I like code as config. I'm like a huge nerd. I'm like, oh, you change the code, then you get a new subscription type and all this stuff. But then as we started hiring more and more people, obviously, like there are folks that are like, I'm not changing Rust code to like get a different subscription. That's crazy. So we moved all of them to the database, which was probably like one of the most insane migrations we've ever done because there were like 200 lines of just data migration in SQL, not like the schema migration. And so, like, I wrote that SQL with the help of Codex, thank you. And then I never checked in the database that it ran correctly because of my overconfidence, the same overconfidence that makes you write a CAD kernel. And so we ended up like merging in the code, and like everything was like working fine in just the schema migrations, but then the data migration, like only half of it basically ran. And so it took down prod. And then I was like, oh, I never looked at the actual migration. And everybody was like, why wouldn't you just look if it turned out the right way? And I was like, I don't know. I just thought it would be fine. I mean, you go through like enough migrations, you get pretty confident in yourself when you write 200 lines of SQL that it will be fine. And so, yeah, that was not good. And basically, the follow-up from that was like, just look after you migrate something. And we need better status pages as like overall something that we need to do. As a startup, you're always just have a whole list of things that you need to do. I'm sure you all understand that. So yeah, at one point, our Cloudflare load balancer is deleted. Super weird. I think like, yeah, the account got into a weird state. So that was like third parties always causing downtime is the worst. Then there was a Frazelle platform outage. And then we had a plan. It's funny because this happened a long time ago. We had a plan to also use Cloudflare, and then we haven't done that yet. Just, again, things get on the backlog, and you never get around to doing them. We have one of our values internally is new mistakes only, so we're not allowed to make the same mistake twice. Okay, so these ones, the next few are like CAD related, which is super interesting. The export command broke, which like if you can imagine in a CAD application, that's like a super important, like you need to export your file in order to manufacture it, send it to someone or whatever. So that was horrible, and somehow we didn't have tests for it, and we're like a super like test-heavy company, and that one was really bad. This is probably the most interesting one. So who here like knows what a fillet is, or a fillet? That's what the French folks call it on our team. Okay, so a fillet in CAD, like this, actually is a chamfer. Chamfers are like flat fillets, but like everything has fillets. Hopefully, if you gain anything from this talk, you'll see fillets all around you. But like everything has fillets because it's the thing that stops you from like cutting your finger on like sheet metal, which this is. And so your phone has a fillet. My phone has a fillet. Like all these rounded edges are fillets. Fillets are like super important to everything, obviously, so that you just don't like slice your finger open. And fillets are also really hard. So like the hardest part of the CAD kernel itself, this is just like weird facts, is surface-surface intersection. And so where two curves like intersect each other. The way in which CAD works, it's an unsolvable math problem, and so you actually have to just like kind of brute force the computation for it. The way most CAD kernels handle this is by doing a bunch of cases, yeah, you basically are like, if this, do this, if this, do this, you all know that. And so that's gross. The way we do it is we brute force it on the GPU. But yeah, anyway, so fillets, two fillets, rounded corners, intersecting is a hard problem. But yeah, fillets regressing is horrible. And the way that we solve this now is we have like hundreds of tests for regressions like this. And then also, like I was saying, we convert our customers' files from one format to another. So now we can run all of the engine tests on customer files as we change things so that we know nothing breaks their files. OK, so as a last thing, I wanted to go over kind of like, since I showed you our architecture, how we're going to do things in the future. So for assemblies, that's multiple parts put together. Like this whole thing is an assembly. This could be like part of it. You know, you get it. The way that we're going to do this in the future is by splitting it up on engine instances, running it in parallel, and then reassembling it back together and rendering it. Today, what we do in KCL is just on the code side, we execute it in parallel. But by doing it on different engines, it should be a lot faster too. Yeah, that should be fairly cool. And we're working on that now. Also, we're hiring if anyone's interested. You can find me after. And yeah, that was what I had. Thank you so much for having me.